Hello everyone, welcome to 10-Minute Physiology. So this is our first video for the Physics MCAT content review. So in today's video, we're going to be examining the difference between displacement and distance. So with that, let's give it a go. So what is displacement? So in order to understand what displacement is, let's bring up a little example. So let's just say we have a car, and this car starts off at an initial position marked as 0 meters. And let's just say that this car moves from its initial position of 0 meters to a final position of 10 meters in a straight line. So what was the displacement of the car? So in order to calculate the displacement of this car, we need to use this equation, where the displacement is equal to the final position minus the initial position. So if we plug in those values, the final position of the car was 10 meters, and the initial position of the car was 0 meters. Therefore, the displacement of the car is equal to plus 10 meters. Now, the reason why I have a plus sign on this is because displacement is a vector, and this means that displacement has both a magnitude and a direction. So this plus sign is basically telling us what direction the car is moving in. So let's now look at another example. So let's just take the same car, but instead of moving in a straight line from 0 to 10 meters, let's just say that this car moves in a half circle. And if we trace out the movement of the car, it would look something like this, with a radius equal to 5 meters. So what was the displacement of the car in this case? Well, in order to understand what the displacement of the car is, we have to bring up our equation again. So displacement is equal to the final position minus the initial position. So when we plug in those values, we see that the final position is 10 meters and the initial position is 0 meters. As a result of this, the displacement is once again plus 10 meters. So what we see from here is two main things. So the first thing is that the displacement describes an object's change in position. And the second thing is that the displacement is path independent. In other words, it only depends upon the initial and final position. So it doesn't matter how an object gets from point A to point B. All that you have to worry about is the difference between point A and point B. So the difference between the initial and final position. It doesn't matter how the object gets from the initial to the final position. All that matters is the difference between the initial and final position. So let's practice calculating the displacement with this practice question here. So a person is standing at the 5 meter mark, and the person then runs from the 5 meter mark to the 60 meter mark. Then the person runs from the 60 meter mark to the 3 meter mark. What was the person's displacement? So take a minute and pause the video and calculate what the displacement is for yourself. So I hope you took the time to answer this question. So the answer to this question is choice D. And the reason why is because the displacement is equal to the final position minus the initial position. So the final position of the person is the 3 meter mark, and the initial position of the person is the 5 meter mark. So when you take the difference between these two, you get a displacement equal to minus 2 meters. So once again, the displacement is path independent. It doesn't matter how you get from point A to point B. All you need to know is the difference between point A and point B. So now that we understand what displacement is, let's talk about what distance is. So let's bring up our little red car again, and then let's just say that this car starts off at a position of 0 meters. And let's just say that this car travels in a straight line to the position of 10 meters. So what was the distance traveled? What we see here is that the total distance that the car traveled is going to be 10 meters. So the distance that the car traveled is 10 meters. So now let's take this same car and move from position 0 meters to the position marked as 10 meters, but this time we're going to move the car in a half circle. So if we trace the movement of the car and we take the radius, we can then calculate the distance that the car traveled. So the distance that the car traveled is equal to 2 pi times r over 2. So we use 2 pi times r because 2 pi times r would give us the circumference of the circle. But since this is only a half circle, we divide it by 2. So as a result, the equation is equal to pi times r. So if you were to input those values where pi is approximated as 3.14 and the radius is equal to 5 meters, what you would get is a distance traveled of 15.7 meters. So the distance is the total amount of x traveled, where x is equal to meters, kilometers, feet, centimeters, inches, whatever the quantity that they're talking about. And it's important to realize that distance is path dependent. So in other words, in order to calculate the distance that something traveled, you need to know the path that that object took. So you need to know if the path was a semicircle, if it was a half circle, if it was a sine wave, or whatever it may be. So distance is path dependent. So now let's do one final practice question. A person is sitting on a Ferris wheel with a diameter of 20 meters. The Ferris wheel then starts to rotate and makes 2 full rotations before it stops. What was the distance and the displacement of the person sitting on the Ferris wheel? So take a moment, pause the video, and find out what the answer is. So hopefully you pause the video. So the answer to this question is choice B, and let's see why. So let's draw a picture. So this is our Ferris wheel, and let's just say that the person is sitting on top of the Ferris wheel in the very top car. So let's just say that this Ferris wheel takes its first full rotation. So after the first full rotation, the person ends up at the very top of the Ferris wheel. And after the second full rotation, the person ends up at the very top of the Ferris wheel. So the initial position was at the top of the Ferris wheel, and the final position was at the top of the Ferris wheel. So using our equation for displacement, we can see that the displacement of the person is going to be equal to 0 meters. And this is because the initial position is equal to the final position. So what about the distance? Well, in order to calculate the distance traveled, we need to calculate the circumference of the Ferris wheel. And we can calculate the circumference of the Ferris wheel by multiplying pi times the diameter. So the distance traveled by the person would be equal to 2 times the circumference. So the distance is equal to 2 pi times the diameter. And when you plug in all those values, what you get is a distance of 125.6 meters. So what we see from this question is that the distance is not always equal to the displacement. And the reason why is because the distance is path dependent. So in other words, it depends how you get from point A to point B. And displacement is path independent. So in other words, it doesn't depend upon how you get from point A to point B. All displacement depends upon is the difference between the initial and final position. So this right here is a table summarizing everything we talked about today, and it's for you to copy down for your studying convenience. So I hope this video helped you understand the difference between distance and displacement, and I hope to see you in the next video. Thank you for watching, and I hope to see you next time.